we covered in this lesson are introduction, what are fractions, types of fractions wherein we will talk about proper, improper and mixed fractions, addition of fractions, subtraction of fractions, multiplication of fractions and division of fractions. We will also discuss decimal numbers, multiplication and division of decimal numbers. Fractions and decimals. Now, even before we talk about what they are, let us look at a very common example, a very common thing that must have happened to many of us. Let's say that you have a pizza. Now, pizza is the best example to understand fractions. So trust me, just think of a pizza when you want to understand fractions. This would give you very nice examples and a very beautiful understanding. So you have this pizza and you have to divide this pizza equally among 5 kids. Let's say these are your friends. So you are 5, so there are 5 of you together, so and one pizza. So obviously you do not want to eat more and give your friends less. So your job is to divide this pizza into 5 equal parts. So what do? You take out slices from the pizza, like as you can see on the screen. So this is how the slices come out, right? So in this way, you divide the entire pizza into 5 equal parts, like this. So let's say 1, 2, 3, 4 and 5. So this is how you have divided it into 5 equal slices, and then you have given 1 slice each to your friend. So now if I ask you, what part of the pizza did each one of you eat? How much pizza did you eat? Now let's say that this is you. So if I ask you that, okay, you ate 1 pizza, so what will you say? That did you eat 1 complete pizza? No, you didn't eat the entire pizza. So how much of that pizza did you eat? So you would say that I ate only 1 part out of 5 parts of the pizza. And what is this 1 part by out of 5 part? This is called 1 by 5, or this is normally named as 1/5. So this actually means that you have eaten 1/5 of the pizza. So what is this 1/5? This 1/5 is nothing but a fraction. So a fraction is always a number which tells you that how much part of the total. So that is what is being told by fraction. For example, when you say that you ate 1/5 of the pizza, so it actually tells you that 1 part out of the 5 parts. So basically it is telling you how much part of the entire pizza did you eat. And that is what is always indicated by a fraction. So that's fraction. Now let us look at this example again. Now let's say out of these 3, so let's say there's one in blue, there's one in red and the other one is in green. So out of these 3 guys, who is more hungry? So let's talk about the same friends who were eating pizza. 5 of you were eating pizza. Now let's say that some of you are more hungry than others. So in this case, this time, there are just 3 friends. So not 5, but 3 friends. And you have 1 pizza. Again, but this time you have a bigger pizza because you are more hungry, right? So what happens is, we see that the first guy, he eats 1 slice of the pizza because he is only that much, he is moderately hungry. So he doesn't want to eat too much. So he ate 1 slice of pizza and he is like, fine. The second guy is quite more hungry. He didn't have his breakfast maybe, so he is more hungry and he ate 3 slices of the pizza. Now this time your pizza is not that small that you have only 5 slices. So this is a big pizza. So you have more slices, or you can also assume that you have more number of pizzas. So this guy ate 3 slices of the pizza. What about the third guy? Now it looks like that the third guy is all the more hungry. So he ate almost 4 slices of a pizza. Now you might be wondering that how come they get so many slices of pizza from 1 pizza. Now in this case, as I mentioned before, that you do not have 1 such pizza. You actually have 3 people and you have 3 pizzas like this. So you have ordered 3 pizzas like this, and each pizza, one pizza is given to each of them. Now this guy, he ate just 1 slice from this pizza. This guy, he ate 3 slices from this pizza. And this fellow, he ate 4 slices from the pizza. So he just ate 1, he ate 3. So 1, 2, 3. And he ate 4. 1, 2, 3 and 4. Now can you tell me that what fraction of pizza did each one of them eat? Now when you look at the first boy, he ate 1 slice out of 5 slices. So he ate 1/5 of the first pizza. So this is called 1/5. What about the second boy? How many slices did he eat? He ate 3 slices out of 5 slices. And what is this called? This is called 3/5. So that means he ate 3/5 of the pizza. And what about the third one? He ate 4 slices. That means he ate 4 slices out of 5 slices. And this is called as 4/5 of the pizza. So these are all fractions. 1/5, 3/5, 4/5, which tells you that how much of the total. So that is what is being defined by a fraction. So let us see what is a fraction. It is a ratio of 2 integers in the form p by q such that q is not equal to 0. Now this is a very mathematical definition, right? So let's take one more example to define fraction. Let's say that this boy is reading a book, and the book has a total of 100 pages. So there are 100 pages in the book, and this boy has already read 50 pages. So total number of pages, total there are 100 pages in the book, and by now the boy has completed, or the boy has read how many pages? 50 pages. So if I ask you that what fraction of the book have the boy already read? So what part, how much part of the book is already read by the boy? So how would you find that? This boy has read 50 pages out of 100 pages. So 50 by 100. What is 50 by 100? 50 by 100 is nothing but 1 by 2. So how do we divide these things? So that we will learn later. So that is what is our aim in this chapter. So basically we find that the boy has read half of the book. So 1 by 2 is nothing but half. So half of the book is already read, and the remaining half is yet to be read. So half is that fraction of the book which has been already read by the boy. Now when you look at half, this is an example of a fraction. What is it? It is a ratio of 2 integers. 1 is an integer, 2 is an integer. Ratio of 2 integers in the form p by q. Here 1 is p and 2 is q, such that q is not equal to 0. Why q not equal to 0? Because if q becomes equal to 0, then the value of this entire fraction will be not defined, because anything divided by 0 is not defined. Therefore, in a fraction, we never want the q to be 0. So basically, when you talk about a fraction, the number which is present at the top is called the numerator, and the number which is present at the bottom or which is present at the down is called denominator. Now how do you remember this? Denominator, D for denominator and D for down. So denominator is at down, and obviously the other one, that is numerator, is at top. So let us look at some examples. So anything of this sort. 4 by 10 is a fraction. 15 by 4 is a fraction. 1 by 3 is a fraction. 100 by 3 is a fraction. So these are all examples of fractions. So anywhere you see ratio of 2 integers such that the denominator is not equal to 0. So that is an example of a fraction. So that's fraction. So let us look at more examples of fraction. Look at this apple. Looking at this apple, if I ask you, what fraction of the apple has already been eaten? So you might say that 2 out of 5 parts. That would actually mean, now you might say that where are the 5 parts in an apple? What it actually means is, in case you divide this apple into 5 equal parts, then I have eaten 2 parts out of those 5 parts. So that is what is called as 2/5. So you would say that if you have eaten some part of the apple, you say that I have eaten 2/5 of the apple. Let's say you are writing exams and you have solved 5 questions out of 20 questions. So far, what have you done? What fraction of the paper have you solved by now? 5 by 20, which is actually 1 by 4. So 1/4 of the question paper has been solved by you, right? Let's say that a boy practices football every day for 10 hours. So every day 10 hours. Now if we ask what fraction of the day does he practice football? Now in a day, how many hours do we have? We have 24 hours in a day, and out of those 24 hours he spends 10 hours in practicing football. That means he spends 10 by 24th of the day in football. So these are all examples of fraction, and everywhere you see it is a ratio of 2 integers such that the denominator is not 0. And also everywhere you see that fraction is actually telling what part of the total, like how much hours of the total day, or how much part of the apple, or how much part of the question paper. So fraction always answers how much of the total. Types of fraction. Now fractions can be divided into many types. Proper fraction, where the numerator is less than the denominator. Now can you tell me a quick recap? What is numerator? What is denominator? Denominator, D for denominator, D for down. So the number which is present down is denominator. Number which is present on the top is numerator. So examples of proper fraction could be 1 by 9. It could be -3 by 6. It could be 1 by 200. So these are all examples of proper fractions, because you see the numerator is smaller than the denominator. And it has also been observed that the absolute value of the fraction is less than 1 of the fraction. When I say that means for proper fractions. What is the meaning of absolute value? Absolute value means non-negative value. The value without considering the sign. For example, here you have -3 by 6. If I ask you what is the absolute value of -3 by 6, the absolute value would be 3 by 6, because we have to ignore the sign. Whether it is a positive sign or a negative sign, absolute value is always positive. So absolute value of 1 by 9 would be 1 by 9. Absolute value of -3 by 6 would be 3 by 6. Yes. Perfect. So that's absolute value. So in proper fraction, we see that absolute value is always less than 1. That means when you actually look at the value of 1 by 9, you would see that this value is less than 1. You take any example. Let's say 2001 divided by 2002. This is also a proper fraction because numerator is lesser. But when you actually divide and see what is the value, you would see that this is lesser than 1. You talk about 19 by 20. Here also this is a proper fraction and the value of this fraction is less than 1. Now, can you guess what would be improper fraction? Just the reverse of proper fraction. So here numerator is more than the denominator. So something like 19 by 18 or -2001 divided by 2000 or -9 by 2. So these are all examples of improper fractions because we see that the numerator, the number on the top is bigger than the number below. So these are examples of improper fraction. And the last one is mixed fraction, which is neither a proper fraction nor an improper fraction. So what it is? It is basically a combination of whole number and proper fraction. So something like this. Let us look at some examples. Say 3, 1 by 2. What is this? Here 3 is a whole number and 1 by 2 is a proper fraction. So 3 1 by 2 is a mixed fraction. So this as a whole is a mixed fraction. Similarly, you think of minus 7 3 by 4. You can think of 3 1 by 10, 1 by 100. So these are all examples of mixed fraction. Now a mixed fraction, one interesting thing about a mixed fraction is that it can always be written as an improper fraction. Do you know how? For example, you have 3 1 by 2. So how do we convert it into a proper or improper fraction? First of all, you will not be able to convert a mixed fraction into a proper fraction. Every time you would get an improper fraction. If you want, you can try it out with a number of mixed fractions. Now first, how do we convert it? You multiply these two and then add these two. So just remember this, a multiply here and an addition here. So what we do is we actually multiply 3 into 2. So that is 6. And with the product we add 1. So basically 3 into 2 plus 1 divided by, the denominator remains the same. It was 2, so it will still remain 2. So it becomes 6 plus 1 by 2, which is equal to 7 by 2. So 3 1 by 2 is the same as 7 by 2. So every mixed fraction can also be written as an improper fraction. Like 3 1 by 2 is written as 7 by 2. Now can you tell me how can you write 3 1 by 100? So here also you will multiply these two and then add this. So basically this would be 100 into 3 plus 1 divided by 100. So this would be 301 by 100. So this is again an improper fraction. Now do you know why a mixed fraction can only be expressed as improper fraction? That's because in a mixed fraction you already have one part as proper fraction. But the moment you multiply it with a whole number, the overall value increases. Right? Because what is happening is the denominator remains the same. There is no change in the denominator. But in the numerator, we are multiplying it with a whole number and then adding something, because of which the value of the numerator is increasing. And whenever the value of numerator is more, it is an improper fraction. Therefore, a mixed fraction always gives rise to an improper fraction. Clear? So that's about proper, improper and mixed fraction. Now here in this lesson we will only deal with the positive numbers, even though fractions can be negative because fractions deal with integers. But just to keep things simple at this level, we will mostly deal with the positive values of fractions. Now again, when we talk about fractions, it becomes important to talk about like and unlike fractions. So what are like fractions and what are unlike fractions? Now those fractions with same denominators are called like fractions. So let us look at some examples. So let's say 1 by 2, 5 by 2, 789 by 2, minus 5 by 2, 0 by 2. All of these are like fractions because all of them have the same denominator, that is 2. So they are all like fractions. Now when it comes to unlike fractions, these are definitely fractions with different denominators. For example, 0, 16 by 5, 1 by 3, 9 by 8. So these are all unlike fractions. Anyways, 0 is a whole number because any whole number can be written as ratio of two integers, because 0 can be written as 0 by 1, 5 can be written as 5 by 1. But here when we are talking specifically about fractions, we are not considering the whole numbers. So let's say for unlike fractions, like here 16 by 5, 1 by 3, 9 by 9 by 8, everywhere you see that the denominators are different. Now even if the numerator is the same, like 9 by 8 and 9 by 7, here the denominators are different, so they are unlike fractions. Doesn't matter whether the numerators are same or not. So when we differentiate fraction as like or unlike, we only compare their denominators. So it is independent of their numerators. Now here you can ask a very, very interesting question. Let us consider these two fractions, 9 by 3 and 21 by 7. Consider these two fractions. What do you think? Are they like fractions or unlike fractions? Now directly looking at them, you quickly compare the denominators. Here it is 3 and here it is 7. So they are different, so they definitely should be unlike fractions. But you know, something very interesting is there. Actually, both of these fractions, they actually represent the same fraction. These are just different ways of representing the same fraction. You know why? When you look at 9 by 3, the value of this fraction comes out to be 3 because 3 into 3 is equal to 9. When you look at the value of 21 by 7, here also the value comes out to be 3. So basically 9 by 3 and 21 by 7, they both represent the same number 3. Hello friends, this video on fractions and decimals part 3 is brought to you by examfear.com. No more fear from exam. Equivalent fractions. So what are equivalent fractions? These are different fractions representing the same number, even though the fractions are different, because like the example which I considered, when you think of 9 by 3 and you compare it with 21 by 7, they are definitely two different fractions. But these two fractions are representing the same number, and that is why they are categorized as equivalent fractions. So equivalent. Now, had we wanted, we could have told them equal fractions, but they are not equal because the fractions are actually different, but they are representing the same thing. That is why they are equivalent. So let us consider this example. Let's say that there is a pizza and this little boy wants to have pizza. What he does? He cuts this pizza into 8 equal halves. So into 8 equal slices it has been cut. And how many slices does he eat? He eats 2 slices of pizza. So that means if I ask how much fraction or what part of the pizza did the boy eat? So the boy ate 2 slices out of total 8 slices. That means 2 by 8, which is nothing but 1 by 4 because 2 into 4 is 8. So basically the boy ate 1/4 of the pizza. So this is one scenario. In another scenario, this another boy is again hungry and he has a pizza. What he does is, instead of dividing it into 8 equal halves, he divided it into 4 equal halves. Right? And then he ate 1/2. So that means he ate 1 slice out of the 4 slices. So if I ask you what fraction of the pizza is being eaten by this boy, it would be 1 slice out of 4 slices, which is 1/4 of the pizza. So whether this boy ate 2 slices out of 8 slices or this boy ate 1 slice out of 4 slices, it is all the same. That's because 2 by 8 and 1 by 4 are equivalent fractions. So 1 by 8 and 1 by 4 and 2 by 8, these are examples of equivalent fractions. Now I hope you understand what are equivalent fractions. They are not equal, they are different fractions, but they represent the same number. So let us consider more examples. So the first example that we would consider is 3 by 9 and 7 by 21. So 3 by 9 corresponds to 1 by 3. 7 by 21 also corresponds to 1 by 3. So this is an example of equivalent fraction. Similarly, 10 by 20 and 4 by 8. So even though they look very different from each other, but this represents 1 by 2. This also represents 1 by 2. So they are again equivalent fractions. Now let us see how do we make equivalent fractions. So if I ask you, make equivalent fractions of 1 by 2. Make equivalent fractions of 1 by 2. So let's say that is a task that is being given to you. So how can you make equivalent fractions? Now 1 by 2. Right? So this is the given fraction. Now if I multiply the numerator and the denominator by the same whole number, will that affect the fraction? No, because when we are multiplying it with to the numerator as well as to the denominator, let's say we multiply both numerator and denominator by 2. So the value of the fraction remains unchanged, because whatever we have multiplied, we have also divided in a way, right? Because if whatever, like it is something like this. Let's say that you have a piggy bank and there are 100 rupees in the piggy bank, okay? So you take out 50 rupees to buy a notebook, and your brother puts in 50 rupees into the piggy bank. So that means the net amount which is there in the piggy bank is still 100, because you have taken out 50 but your brother at the same time had put 50. So that means the total content inside is still 100. So the total amount in the piggy bank remains unchanged. So the same thing happens here. You multiply something to the numerator and you multiply the same thing to the denominator as well. In that case, the overall value of the fraction remains the same. So in this way, by adding the same by multiplying the same whole number to the numerator and denominator, you can make many equivalent fractions. So this shows 2 by 4 is an equivalent fraction. Now instead of multiplying the numerator and denominator by 2, if you multiply them by 3, so what do you get? You get 3 by 6. So 3 by 6 is also an equivalent fraction of 1 by 2. Now instead of multiplying by 3, if you multiply by 4, what do you get? You get 4 by 8. So 2 by 4, 3 by 6, 4 by 8, and so on. These are all equivalent fractions of 1 by 2. In fact, this is how we make equivalent fractions of a given fraction. That is by multiplying the numerator and the denominator by the same whole number. Fine. So this was all about the different types of fractions. Now, how do we compare two fractions? Like on the screen, you see a couple of fractions like 2 by 3, 7 by 3, 1 by 3, 2 by 5. Now, if I ask you which fraction is bigger or which fraction is smaller, how do you determine which one is bigger or which one is smaller? So, the first scenario where we have the same denominator. What do we call these type of fractions? Two fractions having the same denominator. They are called like fractions, correct? So here 2 by 3 and 7 by 3, they are like fractions. So how do we know which is bigger? Now since the denominator is already same, so we do not need to bother about it. So the fraction with a bigger numerator is bigger. So here in this case, one is 2, the other one is 7. Now we know that 7 is greater than 2. Or 2 is smaller than 7. Therefore, 7 by 3 is also greater than 2 by 3. So, this is greater. Now, the challenge comes when the denominator are not the same. In this case, it is 1 by 3. Here it is 2 by 5. So, whether we should compare the numerator or we should compare the denominator. So, that's the problem we have. So, what do we do? So, the first step in this case would be to make their denominators same. So, we have to ensure that we make equivalent fractions of both of these numbers so that we arrive at numbers with same denominators. So how do we do that? So for that, what we do is, the first step for that would be to find out LCM of 3 and 5, that is the denominators. Now, what is LCM? Least common multiple. You remember we had learnt about how to find HCF and LCM in class 6th. If you have forgotten, then refer the videos of maths videos of class 6th to understand LCM in detail. Now, least common multiple means it is a number which is going to be a common multiple of both 3 as well as 5. Now, for 3 and 5, the least common multiple is 15. Right? So, because 3 into 5 is 15 and 5 into 3 is also 15. So, it is a common multiple of 3 and 5. Now, once we have find this out, what we do is you consider both the fractions one by one. So, first we consider 1 by 3. What we do? We multiply both the numerator and denominator by a whole number such that in the product the denominator is 15, because 15 is the LCM. So 3 into what gives 15? 3 into 5. So we will multiply the numerator also by 5. So what do we get? We get 5 by 15. Similarly, we will do it for the other fraction, that is 2 by 5. So we want to multiply the numerator and denominator by a same whole number such that in the result the denominator is 15. So 5 into 3 is 15. So we will multiply the numerator also by 3. So this becomes 6 by 15. So you see here, by looking at this, you can say that 1 by 3 and 5 by 15, these are equivalent fractions because they represent the same value. Similarly, 2 by 5 and 6 by 15, these are also equivalent fractions because they represent the same value. Now it is very easy to compare these two values because you have the same denominator, and in the numerator 5 is less than 6. Therefore 5 by 15 will be less than 6 by 15, and therefore 1 by 3 is less than 2 by 5. So we can say 1 by 3 is less than 2 by 5. So in this way we can compare two fractions. So even if they have different denominators, our first step would be to convert each fraction into an equivalent fraction such that both the fractions have same denominators. And for that we find out LCM of the denominators. So this is the exact process that we follow. So the tip that we need to remember while comparing fractions is that make sure that the denominators are same. Now if it is already same in the question as in the first case, then your job is almost done. If it is not same, then by finding out LCM we will have to ensure that the denominators are same. The one with bigger numerator is the bigger fraction. Now once the denominators are same, one with bigger numerator is bigger fraction. Thank you. Please visit exam. So that means in a way both of these fractions are kind of similar or kind of equivalent, you can say. And this is where we also talk about addition of fractions. How do we add fractions? Now, addition of fractions. This is something which you have learned in detail in your junior classes, but still we will have a quick recap that how do we add fractions. Now, again, there can be two scenarios. First scenario could be adding like fractions, that is fractions with same denominators. Now, in that case, your job is pretty simple. Let's say you have one fraction as 6 by 15 and you have another fraction, say 9 by 15. So how do you add them? You just need to do one thing. You need to add the numerators because in the result also the denominator is going to be the same. So the numerator would be 6 plus 9, which is equal to 15 by 15, which is equal to 1. So this is how we add fractions with same denominators. What about fractions with different denominators? That is the unlike fractions. For example, you have one fraction 6 by 15 and the other fraction is 9 by 5. So they are different denominators. So here also we will follow the same approach. We are going to convert them into like fractions. How do we convert them into like fractions? Again, we will take LCM of 5 and 15. That is, you take the LCM of the two denominators. And what would be the LCM of 5 and 15? This is how we find LCM, right? 5 1s are 5, 5 3s are 15, and 3 1s are 3. So the LCM would be 5 into 3, which is equal to 15. So the LCM of 5 and 15 is 15. Right? So once you have taken the LCM, this LCM is going to be the denominator in the result. So this would be 15. Now what we do is 6 by 15. So 15 into 1 is 15. So therefore what we do is 6 into 1 plus 5 into 3 is 15. So in the numerator we do 9 into 3. So this is the approach that we follow. Very simple. First find out LCM. The LCM of the two denominators would be the denominator in the result. And in the numerator, you find out what is that number which when multiplied by the denominator of this fraction will give this LCM. And then you multiply that number with the numerator. In this case, 15 into 1 is equal to 15. So we multiplied 1 to 6. 5 into 3 is equal to 15. Therefore, we multiplied 3 to 9. So this would be 6 into 1 is 6 plus 9 into 3 is 27 divided by 15. So 27 plus 6 would be 27 plus 6 would be 33 divided by 15. So 33 by 15 would be the sum of these two fractions. So this is how we add fractions. Now let us look at subtraction of fractions. That also is done in a similar way. So when you have fractions with same denominators, like let's say 6 by 15 minus 9 by 15, in that case the denominator will remain the same. We just need to subtract the numerators, that is 6 minus 9, which is equal to minus 3 by 15. So this would be the result. And when you have fractions with different denominators like 6 by 15 and 9 by 5. So in this case again you find out the LCM of 5 and 15. So just now in the previous slide we found out that LCM of 5 and 15 is 15. So 6 by 15 minus 9 by 15. This is equal to, denominator would be 15. Now 15 into 1 is 15. Therefore 6 into 1 minus 5 into 3 is 15. So 9 into 3. So this would be 6 minus 27 divided by 15. So this would be equal to minus 21 divided by 15. So this is the result of subtraction. So for addition and subtraction, so one scenario when both the fractions have same denominator, it is pretty simple. That is, you directly add or subtract the numerators. But when you have different denominators, you take the LCM of both the denominators and then you proceed with the addition or subtraction. So basically this is how we add or subtract fractions.